EduMoon tutorials on big data analytics. Today, let us discuss about the basic building blocks of Hadoop. A Hadoop cluster is a combination of a single master and multiple slave nodes. The master node includes job tracker, task tracker, name node, and data node, whereas the slave node includes data node and the task tracker. Hadoop Distributed File System, in short HDFS. It is a distributed file system for Hadoop. This architecture consists of a single name node which performs the role of master, and multiple data nodes perform the role of a slave. Both name node and data node together can be run on commodity machines. Java language is used to develop HDFS. So, any machine that supports Java platform can easily run the name node and the data node softwares. The name node itself does not participate in the input output tasks. It gives these tasks to the data nodes that are managed by name node. The metadata of system's file is stored in memory. A name node manages the file system namespace by executing an operations like opening, renaming, and closing the files. It is the only master server that exists in the HDFS cluster. As it is a single node, it may become the reason for single point failure. The data node is responsible for the actual task of reading and writing HDFS blocks. HDFS block indicates each individual part that are divided from a large file and continuously reports the status to the name node. The HDFS cluster contains multiple data nodes. Each data node contains multiple data blocks. These data blocks are used to store the data. The other responsibilities of data node are to read and write requests from the file system's clients. It also performs block creation, deletion, and replication upon instruction from the name node. The role of job tracker is to accept the MapReduce jobs from client and process the data by using the name node. Job tracker is the direct point of contact for applications and Hadoop. Whenever a code is submitted to the Hadoop cluster, a job tracker determines the execution plan. It includes deciding which files to process, assigning different tasks to each task tracker. It also monitors all tasks that are under current execution. This is only one job tracker daemon per Hadoop cluster. It typically runs on a server as a master node of the cluster. As with the storage daemons, the computing daemons also follow a master slave architecture. The job tracker is the master overseeing the overall execution of a MapReduce job, and the task tracker manages the execution of individual tasks on each slave node. Each task tracker is responsible for executing the individual tasks that the job tracker assigns to them. Although there is a single task tracker per slave node, each task tracker can spawn multiple JVMs to handle many map or reduce tasks in parallel. One responsibility of the task tracker is to constantly communicate with the job tracker. If the job tracker fails to receive a heartbeat from a task tracker within a specified amount of time, it will assume the task tracker has crashed and will resubmit the corresponding tasks to other nodes in the cluster. A secondary name node is a worker process used in the cluster to monitor the state of the HDFS cluster. Like the name node, each cluster has one secondary name node and it typically resides on its own machine as well. It is also not the same as name node that it does not accept and record any real-time changes in the HDFS. Instead, it deals only with name node and periodically collects snapshots of HDFS states, which are used primarily to restore work when the name node fails. These also help minimize the downtime and loss of data. The MapReduce comes into existence when the client application submits the MapReduce job to a job tracker. In response, the job tracker sends the request to the appropriate task trackers. Sometimes these task trackers fail or time out. In such a case, the part of the job is rescheduled in this layer.